This problem says use synthetic division and the factor theorem to determine if x minus the quantity 3 plus 4i is a factor of f of x equals x squared minus 6x plus 25. Now remember, the factor theorem says that if x minus some number, in this case the number is 3 plus 4i, if x minus that 3 plus 4i is a factor, then that means that 3 plus 4i must be a zero of this polynomial. Well, let's use synthetic division to test to see if 3 plus 4i is a zero of x squared minus 6x plus 25. And if it is, then we know that x minus the quantity 3 plus 4i is a factor by the factor theorem. All right, so I've set up our synthetic division here. First step in synthetic division is to bring down the leading coefficient of 1. And now we multiply the 1 times the 3 plus 4i. That just gives us 3 plus 4i. Now we add negative 6 plus 3, which is negative 3, and then plus 4i. Now we need to multiply 3 plus 4i times negative 3 plus 4i. We'll do that over here on the side. 3 times negative 3 is 9. 3 times 4i is 12i. 4i times negative 3 is minus 12i. So the plus 12i and the minus 12i add out. And then the last step is to multiply 4i times 4i. Well, that's 16i squared. And we know that I squared is equal to negative 1. So we have negative 9 plus 16 times negative 1, which is negative 9 minus 16, which is minus 25. And the minus 25 goes here. 25 minus 25 is 0. So when we divide x squared minus 6x plus 25 by 3 plus 4i, the remainder is 0. That means that 3 plus 4i is a zero of this polynomial. And if 3 plus 4i is a zero, then by the factor theorem, x minus the 3 plus 4i is a factor. So we can confidently say that x minus the 3 plus 4i is a factor of this polynomial because 3 plus 4i is a zero.